This is Steve Barclay from ATIS. We're going to get the webinar started. Just as a reminder for those who may have joined us within the last couple of minutes, everybody is joining in listen-only mode, so you will be muted throughout the webinar. If you have any questions, you can type them into the control panel, and we will answer as many of them as we can, but that would be at the very end of the webinar. Everybody who is registered will receive a copy of the presentation material, which will also be posted. And at this time, I'd like to turn it over to Tom Anderson, who is ATIS Technology Consultant. Tom, take it away.
Great, thank you, Steve. My name is Tom Anderson with ATIS, and welcome everyone to the ATIS 3GPP webinar. When we look at the agenda for today, you'll see a focus on 3GPP 5G in release 15 and 16. Now 3GPP covers a lot of material. As you know, there's a lot of topics in the releases covering certainly 4G and LTE, LTE Pro, etc. Our focus today is going to be on 5G because there's a lot of really exciting things happening there, and this is really an opportunity to get the ATIS membership together on what is happening on 5G and provides an opportunity to affect and follow what's going on. One of the goals of this webinar is really to engage the 5G membership. We do have an active effort within ATIS that works these issues in parallel with 3GPP. It's the WTSC group, and we are very happy to have Farag Katibi as one of the speakers today. And Farag is a chair of the RAN group within the ATIS WTSC, and I believe Farag will say a few more words about that, but we certainly encourage participation in the ATIS work as it contributes into 3GPP, as it allows members within the Americas, North America, to provide a more consistent, consolidated voice for all of the work going on in 3GPP. So from the agenda perspective, I'll start with an overview and a little bit of a structure on 3GPP, just as a review for many, but that structure is always good to review ahead of time, and provide some insight on the schedule for release 15 and 16, the primary 5G releases. We have then a services perspective from Farag Katibi of Qualcomm, followed by a talk on the core network architecture changes with 5G from Stephen Hayes of Ericsson. And we're completing the webinar with a description of the new RAN features and capabilities from Ahmad Farag. And finally, we'll wrap up at the end in the next hour and a half. If we move to the next slide, we have a few bits of information about the speakers. Certainly you see a lot of expertise here. Stephen Hayes, Director of North American Standards, Ahmad with Nokia, an expert in 5G physical layer standards, and certainly Farag from Qualcomm, Director of Engineering, and highly engaged in the whole standards process. As Stephen mentioned early in introducing the webinar, the attendees will all remain muted. If you need to ask a question, you can use the attendee control panel to do that. All of these questions will be recorded or saved, and we hope to have enough time at the end to maybe address one or two of the questions. If not, because we'll end promptly at the allotted time, we will look to address these questions and reply in email, so that don't worry if you ask a question, we will address it and send it out later. And certainly all the slides will be emailed to the participants as well, so you get a copy of those. Now, 3GPP is a partnership project, as the name implies, and there are a variety of organizational partners. ATIS is the organizational partner really representing the North America's interest in 3GPP. So we feel a responsibility to look at the North America constituency and make sure that we've got the right requirements, the right design into 3GPP as fits the North American needs. Next slide. Relative to the organizational structure of 3GPP, there are three major groups, as you see, and starting from the right-hand side, the system and services aspects group, the SA groups, really are of prime interest at a high level of detailed requirements, etc. And we'll actually address those two areas of main interest, the requirements and service aspects and architecture, in the first two talks of our webinar. So as you look at the groups, the SA1 group addresses services, and Farag will spend a good amount of time in his presentation to discuss the services aspects and service requirements for 5G specifically. Following Farag's talk, we'll address the SA2 architecture aspects, and Stephen Hayes or Erickson will do that. And those two groups really, requirements and architecture, really set the stage for much of the 5G work. Certainly there's a lot of other work that needs to go on that's important. SA3 handles security, SA5 handles operation and management aspects, and there's also groups on codec and mission critical applications. But from a starting point, we really, and a good place to start, excellent place to start, is with the work going on in SA1 and SA2. If you look in the middle, the CT groups typically work at a layer of detail that's down from the high-level architecture, the kind of the phase 3 detail of specifications, looking at protocols. For example, CT3 in the middle there is where much of the detail around charging and policy is defined. We're not going to have time to talk a lot about the CT work today, because we want to make sure we get the RAN and the core aspects covered. The farthest left-hand group is the RAN group, and the RAN groups, set of groups from 1 through 6, and the plenary group deal with all of the aspects of the RAN. So if you think of the base station, the air interface, the operations associated with the base station, and interfaces from the RAN aspects back into the core are all dealt with here. And Ahmad from Nokia will talk about the progress in RAN, particularly around RAN groups 1, 2, 3, as far as what's happening there in 5G. I would also like to point out that we're focusing today on the release 15, 16 aspects of 5G, but there's a lot of other work, and there's a lot more detail that we haven't covered. So we really welcome feedback after the webinar, when you do provide feedback about what other topics we should cover in the future, what we should cover in more detail, etc., so that we can meet your needs and cover these things. And certainly you're all welcome to participate in WTSC groups and associated RAN groups there to follow this more closely if you're not able to cover the 3GPP meetings themselves. Next slide. So this last slide in the introduction really is a schedule, and the schedule here is focusing on release 15 and 16, and you can see where we are right now in the green, coming up in the last part of the third quarter and moving into the fourth quarter as we finish up the phase 2 work and heavily commence into the phase 3 work. We hope to certainly finish the basic release 15 work, getting the foundation of 5G with much of the remaining in release 16. And as we work through the presentations today, you'll probably hear some comments about what parts of this should be in release 15, what parts might be addressed in 16 or later releases, since I know that's an interesting topic that people likely will have questions on. Now, there's a lot of work items associated with 3GP and these releases, release 15, 16. Rather than cover them all, since our speakers will cover the key work items that are of focus today, I put a link in the bottom of this chart, which is a link to the set of active work items in 3GPP by release. You can sort by release, you can sort by specific group that has responsibility for the work item, so you can get to see a broader view of all the various activities going on. And with that, I'd like to turn the presentation over to Farag, who will discuss the services perspective, excuse me. Farag?
Thank you, Tom. Thank you. That was an excellent overview. In this section, let me start by a lot of comments, questions came up with what is the activities of ATIS with respect to 5G. And let me start with just a very brief summary of that. We have a number of activities going on in ATIS with respect to 5G. Tom is actually leading some of that activities in the 5G ad hoc that we have. I am chairing ATIS Wireless Technology System Committee, WTSC, and RAN group, which we are very much engaged with the 5G activities, especially with respect to IMT 2020 in ITU, which we will go through it a little bit more. In addition to the RAN group in WTSC, we have SN group, Services and Network group, that covers the services and network aspects. We have a number of other activities with wireless emergency alert, public safety. So we have a number of activities going on in ATIS. The presentation that I'm going to make is really focused on the 5G aspects. So this, the genesis of, many of you probably have seen this slide before, the genesis of how did we come about 5G. One of the first documents and pictures that came up was, let's look at 5G use cases. And this diagram that is borrowed from ITUR shows this pyramid, if you will, or triangular, that shows the three major use cases of 5G, those being enhanced mobile broadband, EMBB, and ultra reliable and low latency communication, URLLC, as well as massive machine type communication, MMTC. So those were the fundamental use cases that we said, okay, if we can build our system around those three, how do we go about doing that? And you can see within the triangular, there are a number of smaller use cases shown that relates to those three major parts. For example, smart city, obviously MMTC may be more relevant to that activity. Mission critical, maybe low latency, reliability is more critical. So this is where the starting point was in ITU to get the use cases understood. As a result of that, there was this what we call spider, that maybe that's my common name for it, the spider diagram, that shows how those use cases translate to capabilities, performance capabilities. And this picture, I like it because it shows how the evolution from IMT Advanced to IMT 2020, how these different capabilities have been changing. And you can see, for example, spectrum efficiency, we want to go from 1x to 3x. Low latency, we want to go from 10 milliseconds to 1 millisecond. So this was the blueprint, if you will, of how we want to evolve from IMT Advanced to IMT 2020. And if we map this thing to the three use cases that I mentioned earlier, you can see this another picture that shows how if you want to do massive communication, which one of those elements, those KPIs relate to that. So this kind of tries to map the previous two diagrams together, showing URLLC, really we need the low latency, we need the mobility, EMBB, obviously we need the mobility and a number of others. And for MMTC, connection density is very critical. So this picture was where we started, and this was a lot of it came out of the IMT 2020 discussions, and as well as other, like there were other groups worldwide that had a lot of discussion to build up these requirements, if you will, for the IMT 20. So that was the background that happened. Then let me start focusing on the activities that happen in SA1 that Tom described earlier, to build up based on the ITU and other groups' requirements. And the first thing, SA1 started with a number of technical reports, TRs, that I listed below. For example, one of them was called Smarter MIUT, and critical communication. But at the end, once those discussions were done, we created technical specification, TS, and that's TS 22261 that was first completed in February 2017. So SA1 usually, it takes a lead to define all those requirements. And it has some really interesting characteristics. For example, there was this long debate on UE versus IoT that they finally defined it, and there's some description of it, and there's some annex on different aspects. For example, factory process automation, electricity distribution, intelligent transportation use cases. So there's a lot of good stuff in this TS 22261. What I'm planning to do is give a very brief overview of those, because honestly, if I want to talk about all the stuff that's going on in 22261 in 3GPP with respect to requirements, that by itself probably takes a 90-minute at least discussion. So with that, let me just give a brief overview of what's going on. I've listed some of the interesting requirements that came out of 22261 discussion, and you can see, and I will go to a little bit more detail in some of these. Alternative authentication, neutral host, third-party slicing, and security aspects, backhaul, network selection and optimization. So there were a lot of really interesting concepts that came out of it during the discussion of the requirements of 5G in SA1. So what I will do now, just cherry pick a few of them. And as I said, if I go through all these things and really discuss all of them, it would take a long time. So I cherry pick a few of them to see how to address it. The first one is an interesting one. It talks about how there is limited backward compatibility with 4G, but not much to 2G and 3G. This is one of the requirements that was captured in 22261, and they're saying that there should not be any, the exceptions are there should not be any CS voice continuity to GRAN and UTRAN, seamless handover between 5G RAN and GRAN, and UTRAN and GRAN and UTRAN. So this backward compatibility, one of the first decisions that was made is to scope it out to make sure that there is a clear framework on what are the backward compatibility between 5G and previous generations. The security aspects is always interesting and always important. So some of the security issues are listed here. And what I'm going to do from here on, I'm not going to read all the bullets, but I will highlight a few more interesting ones. For example, with respect to 5G, the first one is how 5G shall support operator control alternative authentication methods. And I think Stephen has a little bit discussion on that as well. And this is with different types of credential. And there's a lot of, I see a lot of flavor of IoT discussions here. And this is especially for IoT devices in isolated deployment scenarios. So this was one of the ones that I thought it would be interesting to highlight. Another one is the 5G system shall be able to support identification and subscription independently of identification of equipment. So we are kind of doing the separation between the subscription and equipment. The next interesting requirement that I thought it would be worthwhile highlighting is this concept of wireless self-backhauling. And the idea is that you want to, the spectrum is important and so forth, and you want to give the ability to do the self-backhauling. For example, one of the requirements is 5G network shall enable operators to support wireless self-backhaul using NR. So we're going to throw this term NR a lot. That means new radio, or if you will, just 5G. So when we say NR, we really mean this new radio and 5G and EUTRAN. Then the other interesting one is that 5G network shall support flexible and efficient wireless self-backhauling. So this is, again, going back to the self-backhauling for both indoor and outdoor scenario. So these are really interesting concepts, and there are some regions that are really interested to make sure this self-backhauling happens very interesting. People don't realize that often backhaul costs a lot of the total deployment, so the self-backhauling can be very powerful in 5G. Another one is support of autonomous configuration of access and wireless self-backhauling, so automatically be able to connect and do this configuration. The next requirement that I thought it would be interesting to discuss is provisioning and network selection. For example, based on operator policy, the 5G system shall support a mechanism to provision on-demand connectivity. This on-demand mechanism should enable means for a user to request on-the-spot network connectivity. It's a pretty powerful requirement that we are describing here, while providing operators with identification and security tools. So we want to have on-demand connectivity, but not compromise any of the security aspects. The other one is support a secure mechanism for home operator to remotely provision the 3GPP credentials. This is another important, because like often we have this, remote devices, and we want to make sure that the carriers would be able to remotely provision their credential. So you want the carriers to be able to uniquely identify and verify security devices. And this becomes very interesting, especially with IoT, that you may just deploy a large number of IoT devices, and you want to make sure that you provision them and understand their security aspects, which is critical to the security of the system. The other one that it's kind of really exciting about the whole 5G discussion, the concept of slicing. We've been talking about NFV and etc. a lot, and slicing by itself, network slicing, it's a very interesting concept, and I think Stephen's going to touch upon it a lot more details from the network and architecture's perspective. But there is also this concept of third-party slicing that I would like to go a little bit to it. One of them is that 5G system shall allow the operator to create, modify, and delete a network slice. Pretty interesting concept that we want to allow. Another one is the 5G system shall allow the operator to assign a device to a network. So once you have this network slice, we want to allow the operator to assign the device to a particular, like if you have a critical communication device and you want to have low latency and ultra reliability, there should be a way to do that assignment. And also we want to be able to allow for the device to move from one network slice to another network slice. So if the same device was assigned to a slice that for the auto LLC, your LLC, and we want to move it to EMBB, we should be able to allow to do that. So, and we want to be able to allow the device to remove or move and change the subscription. So we are giving full flexibility to the carriers to assign the device to different devices, to the different slices, and move between them. There is another one that would be interesting, is that the 5G system shall allow the operator to authorize a third party to create. So this is not only the carriers, but the third party to create, modify, and delete the network slice. Again, it's powerful, especially like when you think about concepts of a public safety device potentially sharing the network with a commercial device. So this would enable some of those capabilities that we were talking about. Then there is this concept of subscriptions aspects that I thought it was interesting. One of the ones that I just want to point out is the 5G system shall be able to support identification subscription independently of identification of IoT device. So again, this concept of we want to have subscription that's not really tied to the device comes into, so both identities shall be secure. So we want to make sure that both the device and the subscription are very secure. And the last one I want to talk about with respect to subscription aspect is based on operator policy. The 5G system shall support a mechanism to provision on-demand connectivity. This on-demand mechanism shall enable should enable means of a user to request on-the-spot network connectivity while providing operators with identification and security tools for the provider. So we are providing a lot of tools for both the operators and third party to be able to manipulate and work with the subscription. So the last thing I want to talk, and again, I'm sorry, I'm going through these things a little bit quickly. As I said, we only have 20 minutes each to talk about, but there's a wealth of information available, and we certainly would invite questions and we would answer the question offline. But I just want to give a kind of like, if you will, landscape of the activities that's going on in SA1. But there's actually more activities coming on SA1, and this last slide talks about it. There are a number of new activities happening. One of them is LAN support in 5G. That has been discussed quite a bit. Positioning use cases, that of course is always important. We have a very good position, and and emergency services and so forth. So position is always becomes important in 5G. Public warning systems in North America, we call it wireless emergency alert via in ETWS and so forth. Those are still very critical on the agenda for carriers in 5G. So there's a study on that. And obviously, and of course, the vertical domains like automations, automatic automation in vertical domains, that's another feasibility study that's being worked at. And last week, there was an SA1 meeting just last week. And in that SA1, they approved a number of new feasibility studies, including satellite access to 5G, IMS for new RTC services, MIoT messaging services for MIT, and also business model for network slicing. So there's a lot of interesting activities going on in SA1 that I just want to give you a little bit of flavor of what's going on. And with that, I will now pass the discussion to Stephen Hayes, who is very much involved with the SA2 and network aspects, and he will give more details from the stage 2 perspective.
Thank you, Farag. One of the parts of 5G that doesn't get discussed very much is what's happened with the core network. Most of the attention gets paid to the RAN, but there have actually been substantial changes and developments in what is going to be part of the 5G core. When the work first started out, people weren't quite sure where the new 5G core would be, sort of a slightly improved version of the previous one, the LTE core, which was called Evolved Packet Core. But it's turned out to be substantially different and substantially generalized, substantially more forward-looking. And so what I wanted to do today was talk a little bit about some of the changes that have been made to the core network to improve it as part of 5G. So the status of the work right now is, as Farag indicated, most of the work is occurring in SA2, but there are a few other parts that are occurring within 3GPP. In particular, SA3 that's doing security has been a big part because that's very much tied in with the overall architecture. The authentication process is sort of an integral part. And the situation right now is that there's two main projects going on. There's a big one, which is the 5G core, which is developing a new core that will support the new radio. There's another one called EDC E5, which stands for EPS dual connectivity for 5G, which is basically about what has to be done to extend EPC to support the NR core, and that's a much smaller one. And in a little bit, I'll hit on exactly sort of what the distinction is. But the status right now is that the big study, the 5G core, is supposed to complete in December of this year. And most of the architectural principles have been agreed at this point. There's still a lot of detailed work that's going on and sorting out how the different functions work together. But the form of the new core has definitely taken shape. In addition, work has actually started in the CT groups that are doing, they'll be doing protocol and API work to support this new core. So let's go ahead and jump forward. What I've done here is take a look at some of the new functions. Now, there are many more functions that have been changed, but I tried to pick out some of the major ones that represent changes from the previous core, the EPC, to the new core. And so I don't want to dwell on this slide. What I'll go through is in the subsequent slides, each one I'll talk a little bit about what exactly the changes are. But this gives sort of a summary list of kind of the major changes that you see between the previous core and the new core. So let's go on and jump into the individual changes. I mentioned the difference between the two projects, the 5G core and the EDC-E5 project. As part of this, as part of developing the next generation core, a whole new set of signaling for the radio network was developed. And so the next generation core, if you look at the picture on the right, that can communicate directly with the new radio. So everything is optimized to support the new capabilities. If you look at the one on the left, that shows you're still using EPC, and the way it connects to the new radio is to use the existing LTE network as a bridge. So it continues to use the existing EPC protocols, and then in a method called dual connectivity, the new radio is used as kind of an additional access. So the full capabilities are available on the right, but you can use NR in the method shown on the left. And these represent the two projects I indicated, the new 5G core and the enhancements to EPC. So let's go to the next one. Okay, Farag talked about network slicing. And network slicing is one of the major new functionalities that exist as part of 5G. Now, a lot of this was built on functionality that already existed in EPC. There was a project called Dedicated Core Networks, which allowed you to communicate with partition of the network. But network slicing has expanded on that considerably. One of the capabilities is that, as with ED Core, UE is now very much involved in the selection of the slice that you're on. Previously in D-Core, for example, it was basically a subscription type service with the UE not being available. As part of EPC, you could only be in one slice with networks or one dedicated core network. With network slicing, you can have up to 8 active slices at a time. In addition, the RAN is aware of the slices, so it can optimize its functionality also. And you can better isolate functionality both within the RAN and within the core network. In addition, you need to deal with the concept of roaming. Now, one of the problems with slices is they're very customized. And the way this has been dealt with is to define some standard slices. And right now, 3 standard slices are defined. Those are the ones for enhanced mobile broadband, ultra reliable, low latency communication, and massive machine tap communications. So those 3 slices are ones that actually can even be used when roaming. Another big discussion has been on the introduction of something called a service-based architecture. Now, in EPC, if you looked at the network diagrams, you saw something like what was on the left. You saw a lot of nodes connected by point-to-point lines. And the flows and description of how the system worked basically came down to one network node sending a message to another network node which did something. So there were flow diagrams that described the flow between individual nodes. This has been replaced by a service-based architecture where instead of dealing with the point-to-point protocols, you have network functions that provide services to other functions. And then you have discovery functions, registration functions, etc. So that instead of having so much of a point-to-point description anymore, what you have is services that make use of other services to build functions in a more layered approach. The work is still going on right now to convert this into concrete descriptions of how these services are used to build the functions that you need for a functioning network. But this approach has been taken as a generalized way of dealing with sort of the explosion of interactions that occur within the 5G network. And this is a very powerful approach. Let's go on to the next slide. One of the things that you also see is that you have a generalization of a lot of the functions that previously existed in the LTE core. And some of these functions have new names. In the LTE core, a lot of those functions were very much access dependent. Now they've been generalized. So you now have a generalized access and mobility function, a generalized session management function, and user plane functions. In addition, the interfaces to the radio network, N1, N2, and N3 interfaces have also been generalized. So the intention is that the core network is much more access agnostic than the LTE core network. Let's go on to the next slide, please. Another big change is with quality of service. For those that are familiar with the EPC and LTE network, you knew that a bearer-based model for quality of service was developed, and you had bearers with certain quality characteristics and a certain number of different types of bearers. The bearer model has been replaced with a flow-based model. And so now instead of having bearers, we have flows, and the packets are actually marked on those flows. It's a much more generalized model. And instead of having only standardized QoS classes, you can have both standardized and non-standardized QoS classes. There are also additional QoS classes, standardized QoS classes that have been created past the 7 classes that previously existed with LTE. In addition, the handling of the QoS that occurred in the CN and in the access network have been made independent. And this, of course, ties in with the need to support different types of access networks. So essentially what's happened is we have now a much more generalized QoS model, much more flexible, that can handle other types of accesses, and it can handle things like reflective QoS, etc. So that's one of the other changes, is that this overall generalization of the QoS model and getting away from the bearer concept. Let's go to the next slide. Session management. One of the functions or ways that the previous network worked is that IP address preservation was always there. Once you start a session, the IP address remained constant throughout that session, regardless of whether you needed it. And for many applications, IP address preservation wasn't really mandatory. This has been generalized now. And we now support different session continuity modes. There's been a separation of the session and mobility management so that your ability to have a session and your ability to move are now treated differently. In addition, the separation of service continuity and session continuity has been added in. You also have more flexibility in how you route your traffic depending on the type of session that you're setting up. So in general, what you have now is just a much more general model of session management. So you can have things like the ability to separate to have IP address preservation when you want it and skip it when you need it, and more ways of handling traffic routing to optimize the user plane and control plane flows. Let's go into the next one. Okay, two more. Mobility. We've now added the capability to have on-demand mobility, which means that it's implemented with something called service area restrictions, so that instead of having full mobility, which is what always existed previously, you can now specify whether you want mobility only within restricted domains. This gives you the ability to have nomadicity. In addition, there's been a migration of mobility functions from the core network to the RAN, and one of these is supporting a new mode in RAN, RRC inactive, which is basically the device is connected, but there's no signaling occurring toward the device. And this is something that is useful with IoT, for example. So there's been enhancement of mobility. For the policy framework has also been enhanced. Previously, there was a policy for QoS, a policy for ANDSF, which was for device policies, mobility functions, etc. Now we've got one generalized policy framework that all these policies fit in. In addition, most of the previous policies were static. Now we allow network analytics as an input into that policy, so those policies can be changed dynamically depending on the conditions within the network. And then let's go to the next one. And the final one is work that's been done with security. And a lot of this occurs as part of the moving toward a more generalized framework. The previous mechanism, which was based on EPS, has been generalized, and now most of the authentication architecture is based on the more generalized extensible authentication protocol using that framework. In addition, credentials beyond those for USIMs are now supported. There are some minor enhancements such as EPS, aka star, that have been done. In addition, there's some additional privacy protection that's been implemented. But in general, there's just been a general upgrade and generalization of all of the overall security framework for 5G. Next slide. I think this may be the end. And that was a quick run through, a very quick run through of some of the key components that are different between EPC, the LTE core network, and the new 5G core network. Thank you. Next, I want to turn it over to Dr. Ahmad Farag, who's going to talk about some of the 5G RAN features and capabilities. So I'll hand it over to you, Ahmad.
Thank you, Stephen. Good afternoon, everyone. My name is Ahmad Farag. I'm a 5G physical layer standards engineer at Nokia Bell Labs. And today I'm going to be talking about the 5G RAN features and capabilities. I'm going to start by giving a short overview of the 5G vision, then move on to talk about the 5G timeline in the 3GPP RAN. The bulk of the presentation will be spent on features and capabilities, the enabling technologies that are being developed for 5G. So let's start with the 5G vision. So if we look at what 5G really is, and this comes from the ITU framework that Farooq talked about earlier in the presentation today, it's a unified mobile communication framework for a connected and mobile society, supporting different types of applications, supporting high data speed applications, mission critical communications with ultra reliable and low latency requirements, as well as connecting billions of devices together that could autonomously communicate with each other. All of this being supported everywhere and in different types of deployment scenarios. In addition to that, there are diverse spectrum requirements with different frequency ranges, ranging from sub 1 gigahertz to 100 gigahertz, different spectrum licensing model, different types of duplexing and aggregation schemes, while coexisting with legacy radio access technology. So this sets a very high level requirement of what 5G needs to do. So if we could go to the next slide. So 3GPP started looking at 5G in 2015. In the late part of 2015, 3GPP started studying the channel models for above 6 gigahertz, going up to 100 gigahertz. And this study was completed in the middle of 2016. Then there was another study that started in the early part of 2016, and this was to look more at the requirements, the scenarios, and the use cases for the next generation radio access technology. And this was shortly followed by a study on the enabling technology for the next generation radio access network. And we'll talk a bit more about those enabling technologies in the later part of this presentation. But this study was completed in March of this year, and 3GPP issued technical reports that detail the results of this study. And just as a side note, a technical report is really not an implementable standard. It just provides technical solutions to meet the standard requirements, and the technical specification is actually what is in the implementable standards. So after the study item was completed in March, the work started on the work item with the detailed standardization work for NR release 15. And just also as a side note that NR is the name of the 3GPP 5G radio access technology. So with that, let's move on to the next slide. So 3GPP is following a phased approach for standardizing NR. The first release, which is release 15, is focusing on the urgent market needs for enhanced mobile broadband, EMBB, and ultra reliable low latency communication, URLLC, while being forward compatible with future features and releases. Then the second phase, release 16, this will focus on the other requirements of NR, and work on that is expected to begin in the second half of 2018 with a target completion date towards the end of 2019, and this is leading up to the submission of NR at a 5G standard to the ITUR. Even within the release 15, there is prioritization. So the first step is to focus on non-standalone NR, which is targeted to be complete by the end of this year, and then standalone NR, or the complete release 15 feature set, which is targeted to be completed around the middle of 2018. So I'm going to talk a little bit more about what standalone and non-standalone are in a later slide, but maybe we could go to the next slide. So while the work is going on for the release 15 standard of NR, there are also study items that are being worked on or about to be worked on for the other features of NR, hopefully to be standardized in release 16. So this is a list of the NR study items that have been approved by the RAN Technical Specification Group. And just one point to highlight that actually some of those study items, especially the ones that are being led by the RAN Working Group 1 and RAN Working Group 2, these are put on hold or postponed because of work ongoing with the actual release 15 standardization. So we could move on to the next slide. So this slide gives an overview of the 5G specification. There is a new series of NR specs. This is the 38 series. And just like previous standards within the 38 series, each RAN working group has its own series of specs. So if we focus more, let's say, on the 200 series, which is what the RAN working group 1, the physical layer specs, is doing, we find that it's organized in a way quite similar to the way it's organized in LTE. Maybe two points to note here is that there is a new spec, the 38202, which is the services provided by the physical layer. Also, the physical layer procedure spec, which was growing to be too large in LTE, now has been divided into two specs, one for control and one for data. And I provided here a link to the specification of the various working groups. If you go there, you will find that these specs, the 5G specs, are listed there, but there isn't really a lot of information. That's because they're currently in draft with target completion towards the end of this year. Next slide, please. So I talked about standalone and non-standalone, and Stephen also touched on this in his presentation. So in non-standalone NR, we actually have two radios. So we have dual connectivity between E-UTRA or LTE and NR. And in this case, the control plane, including mobility functionality, is anchored in the E-UTRA, and NR just provides additional U-plane capacity. The figure shown here is for the option 3 series, which had the core network at the 4G core network, the EPC. And this is the option that is being standardized with target completion by the end of the year. It's also possible to have a 5G core, the next generation core, at the core network. This then becomes the option 7 series. If we look at the figure on the bottom, so this is the standalone version of NR, and this is where we have both the control and user plane residing in NR, and that's in this case connected to the 5G core network. And maybe just as a side note here also that the NR base station is known as the G Node B. So next slide, please. The RAN internal interfaces allow the splitting of the RAN processing between a centralized unit and a distributed unit, and there are different places where this split can take place in the radio interface protocol. So there are two options for split. There is a higher layer split, which is currently being standardized in release 15, and the option selected there is option 2, which is between the PDCP layer and the RRC layer. There is also a lower layer split that is being studied in release 15, and 2 alternatives are being considered there. One of them is within the PHY, the other one is between the PHY and the MAC layer. So eventually the study item will recommend one of those to be the lower layer split. Next slide, please. Okay, so this slide provides a high-level comparison between LTE and NR release 15. I'm not going to spend a lot of time here because in the next slide, we're going to look at the NR features in more detail. So maybe we could move to the next slide. So the waveform adopted for NR is OFDM, orthogonal frequency division multiplexing, with scalable subcarrier spacing. In the downlink, we have CP or cyclic prefix OFDM, and in the uplink, there are 2 waveforms. We have CP OFDM, which is supported in all use cases. There is also DFT spread OFDM, which is a single carrier OFDM, and this is supported in budget limited scenario where the link budget is limited because of the low peak to average, low PAPR of DFTS OFDM. One point to note also in NR is that in uplink, there is no 7.5 kilohertz frequency shift that was there in LTE. Next slide, please. So one of the enabling technology in NR is to have a scalable numerology. We know in LTE the subcarrier spacing was 15 kilohertz, but NR allows a subcarrier spacing that ranges from 15 kilohertz to 240 kilohertz in power of 2. The higher subcarrier spacing can allow larger bandwidth and also lower latency because the slot duration is now shorter. However, the lower subcarrier spacing allows for a more robust delay spread design, so it's more robust to delay spread. So having different numerologies allow the adaptation of the subcarrier spacing to the carrier frequency, the deployment scenario, as well as the use case. And another key technology being introduced in NR is the support of mini slots. So mini slots are actually also being introduced in LTE, but they will be further enhanced in NR. And mini slots are important to be able to support low latency operation. The figure on the right here shows the time structure within NR. We have frames and subframes, and these have fixed durations of 10 milliseconds and 1 millisecond respectively. This doesn't change with the numerology. The slot duration, on the other hand, is always 14 symbols or 12 symbols with extended CP. So the duration of the slot, the absolute duration of the slot, depends on what the numerology is, and the number of slots within a subframe will accordingly depend on what the numerology is. Next slide, please. NR defined maximum and minimum bandwidth depending on the frequency range. So for below 6 gigahertz, the maximum bandwidth is 100 megahertz. So this is already 5 times larger than LTE. And for millimeter wave, the maximum bandwidth is 400 megahertz. Also, the subcarrier spacing is tied to the frequency range. So for below 6, the subcarrier spacing can be 15, 30, and in some cases 60 kilohertz. For millimeter wave, the subcarrier spacing to be used is 60 and 120 kilohertz, and also 240 kilohertz is supported for the sync signals. And this makes sense that we use lower subcarrier spacing for lower carrier frequencies and a higher subcarrier spacing for higher carrier frequencies. The example shown here on the right shows how NR can provide an increase in throughput that is 21 times more than what we have in LTE. So, and that's thanks to having a subcarrier spacing that is 8 times more than LTE. The FFT size in NR can be double that of LTE. So in LTE, the maximum FFT size is 2K. In NR, the FFT size can go up to 4K. And also the spectrum utilization is higher in NR. Next slide, please. So another enabling technology in NR is the sync design, and the sync design is allows the support of multi-beam systems. It's made up of sync blocks, and the structure of the sync block is shown here in the upper right part of the slide. And each sync block can be assigned to a different beam. The sync blocks together form a sync burst set, and this allowed a sweep of the spatial area with the number of sync blocks allocated to a sync burst depending on what the carrier frequency is. So for low carrier frequencies below 6, it's limited to 4 or 8. Above 6, we could have 64 sync blocks, so being able to sweep 64 beams. Next slide. So this slide here shows the SS block pattern for carrier frequencies less than 6 gigahertz. And when this pattern was designed, there were several constraints that needed to be taken into account. So one of them was coexistence with LTE. Another was supporting TDD and having some symbols kept for uplink that can't be used for downlink, so can't be used for sync. And then being able to have a mix of different data and sync numerology. There is always one pattern allocated to each frequency band. And the maximum duration of the sync burst is 5 milliseconds. So this limits the on time of the UE for UE power saving. Next slide, please. So moving on to RATCH. RATCH uses a 4-step RATCH procedure like LTE, but there are new use cases for RATCH here. It includes, so in addition to initial access and handover, which is already there in LTE, we use RATCH for beam recovery and for on-demand SI. Also during initial access, RATCH has to be able to support a multi-beam system. So there is an association between the sync blocks and the RATCH resources, such that if a UE detects a certain sync block, it will use the corresponding RATCH resource. This allows the network to know which beam the UE is in when communicating with the UE. The RATCH sequence design, there are 2 sequence lengths, a long sequence and a short sequence. The long sequence is similar to LTE, except it could support subcarrier spacing of 1.25 as well as 5 kilohertz. The short sequence length is designed to be able to support efficient beam sweeping, as well as to allow the same subcarrier spacing for RATCH and data, and by having the same subcarrier spacing for RATCH and data, we could simplify the implementation. Next slide, please. So NR MIMO is designed to handle different multi-antenna schemes ranging from analog beamforming to hybrid beamforming to digital beamforming. It has several procedures. So for the beam management procedure, this is designed to be able to determine the best beam, and then it allows for beam failure detection and recovery. Multi-antenna schemes are designed to support single user and multi-user MIMO, and to have up to 2 code words in the downlink. There are several reference signals designed in the downlink and uplink for several purposes. There is a demodulation reference signal, a channel sounding reference signal, phase tracking reference signal, as well as find time and frequency tracking. And then for CSI measurement and reporting, there are two types of CSI feedback: normal feedback, and this has at least two-stage precoding, and it allows supporting of two-dimensional antenna. And there is enhanced CSI feedback with higher spatial resolution. Next slide, please. So NR, as we said earlier, is required to support different types of services. There will be services that require high data rate, as well as services that require low latency and ultra high reliability. So there are some technologies that are being introduced to allow that. One of them is to have different types of slots, ranging from downlink slots, uplink slots, or bidirectional slots that could either be uplink centric or downlink centric, and these slots can be allocated in a dynamic manner depending on the use case, whether it's a high reliability use case or a high data use case in one direction. There are also some technologies that have been introduced to allow for ultra high reliability. One example is the self-contained slot, where both the data and its HARC acknowledgement are being sent in the same slot. The HARC timing is also allowed to be flexible depending on the service requirements and the UE capabilities. As I mentioned earlier, there is mini slots that support low latency applications. Also, there is uplink grant free transmissions. This saves the time the UE has to send the scheduling request, and on top of that, the scheduling request themselves, they can have shorter periods. So all of these techniques help support low latency, ultra reliable traffic while supporting high data traffic at the same time. Next slide, please. So one of the big discussions in the NR study item was the type of channel coding to be used. And there are some criteria that channel coding has to meet in terms of high performance, low implementation complexity, low latency, and being flexible enough to handle different block size and different code rates, as well as to support HARC. So there were, for data channels, 3 competing coding schemes: turbo codes used in LTE, LDPC codes, and polar codes. And after extensive analysis and simulations, LDPC was selected because it provides better implementation advantages and lower latency than other coding schemes. For control channels, polar coding was selected, except for small size blocks where Reed-Muller type coding similar to LTE is used. Next slide. So this is the last slide. It's about future compatibility. So one of the key requirements of NR Release 15 is to be future compatible to releases and functionality that are going to be introduced in upcoming releases. And there are several aspects that allow for that. For example, having a synchronous downlink and uplink HARC with dynamic timing indication, minimization of the transmission of the always-on signaling, as well as having dynamic TDD and bidirectional subframes and self-contained slots. All of this, in addition to reserving some resources for future use and indicating this to the user equipment, helps in making NR forward compatible to new features and releases. And with this, I completed my presentation. So let me turn it over to Tom now.
Okay, thank you very much, Ahmad. And thanks also to Stephen and Farouk. We have a number of questions that were raised, and so we can use, we do have some time, so we'll, let's cover some of the questions. Well, first of all, I want to repeat that the presentation, as well as any unanswered questions, will be available for the participants, and we'll send out a link later on for you to capture those. So don't worry about taking too many copious notes on the material of the slides itself. So the first question, let's start with Farag, who had the first technical talk here, and there's a couple questions here for Farag. Well, the first one is a clarification. I think, Farag, it was you who talked about self-backhaul, and I'm wondering if you could say more about what that is, just kind of define it and how you see that being used.
Yes, thanks. With respect to backhaul, was that the question you were asking?
Yeah, I think you used the term self-backhaul.
Yes. So the idea is that, once we have the base station deployed, carriers would like to use the same spectrum, but not only transmit information between the base station and the devices, but also use the spectrum to provide backhaul. That normally, you need fiber or Ethernet or something, but why not take advantage of the same spectrum potentially to have the backhaul? So, and we have this configuration that we can do automatically deploy the system. So that concept, when you have that self-backhauling, becomes very popular, very powerful. That would allow the system to be deployed a lot more efficiently.
So this is like enhancements to the LTE relay capabilities that were introduced?
Exactly, sure.
Okay. So Farag, another question came up on the question of network slicing, and you had mentioned that we do support simultaneous or at least multiple slices per device. And the question is whether an operator can actually simultaneously assign slices, device to multiple network slices and actually enable simultaneous handling of services from the single device to multiple slices. So is that all simultaneous, or are there some limitations there?
So the answer is yes, but Stephen, would you elaborate on that a little bit more?
Yeah, a device can simultaneously support up to 8 slices. Now, the actual packet data, each slice will have its own data communication or set of packet data units. They won't share that, but you can have, according to the specification, up to 8 of them active simultaneously, 8 slices active simultaneously per UE.
Yeah, Tom, that was it.
Yeah.
Okay, great. Stephen, while you're on, Stephen, if you could comment on virtualization aspects. Are there any particular capabilities in the 5G core network design that really allow you to leverage NFV better or worse, or how does the work in SA2 relate to all the virtualization and NFV work going on?
The virtualization work really isn't occurring in SA2 because to a large part, virtualization or not is transparent to the actual architecture. Where you see the virtualization work actually occurring is SA5, where they're trying to integrate the management aspects of a virtualized network and a 3GPP network together. But in terms of the actual functionality served by a network function, the architecture has been developed doesn't distinguish whether it's a virtualized a network function that's implemented using virtual means or physical means.
Okay, very good. I guess one more question, Stephen. When you talked about policy, you had the AMF listed as far as uniform policy, and could you describe what the AMF is, and are there new policies, and what policies might be associated with that, and how might that look going forward?
Okay, AMF stands for Access and Mobility Function. So it's the one that controls sort of which access you're allowed to use and the types of mobility that you're allowed to have. So for different devices, you could have policies saying if it's a machine type communication, it shouldn't be allowed to roam, or it shouldn't be allowed to move outside of a certain area, example, or it may only be allowed to use certain accesses or certain times of day. So policies that restrict either the access functionality or the mobility functionality, those would be part of the AMF policy.
Okay, great. Yeah, that sounds like a great enhancement to the specifications. A few questions for Ahmad on the RAN. On slide 12, Ahmad, of your presentation, does the bandwidth, is that applied to release 16 as well, is the question?
Yeah, so this is what is defined for release 15, and these definitions came from the working group 4 from RAN 4. It is possible that these bandwidths could be revised or more bandwidths added to this list in release 16.
Okay, so I guess maybe one of the concerns is relative to say IoT, and I sounds like IoT is not a particular focus for the release 15, but there was a lot of discussion around using very narrow bandwidths in IoT below 6 gigahertz to fit into guard bands and things like that. And I think you're saying there that these kinds of issues might be addressed in release 16.
Exactly, yeah. So MMTC or IoT in general is not part of the release 15 requirements. Release 15 is focusing more on EMBB and URLLC. So in release 16, if IoT does become a requirement there, then the bandwidth issues would also be addressed.
Okay, great. Speaking of bandwidths, this is quite this is the same meaning of bandwidths, but there's also a question, Ahmad, about whether you can provide any comment on release 15 and 16 carrier aggregation. Is there any, will there be any carrier aggregation capabilities requirements relative to new radio?
Yes, so there will be carrier aggregation requirements, and actually in the table I have in slide 9, it showed that in release 15 we can have up to 16 carriers being aggregated.
And does this include carrier aggregation, or maybe the better question is, when we look at the new radio, especially when it's used in millimeter wave situations, there's a lot of service level discussion around, well, you'd want to somehow aggregate millimeter wave with lower frequency spectrum, which may be on an LTE radio, so to speak, so that if the millimeter wave drops, you still have connectivity through the lower spectrum LTE connection. Is there any work going on how that might work, particularly with the radio, just the interplay of LTE and various carriers, especially at the higher frequencies in millimeter wave with new radio?
So yeah, so there is work ongoing in that area, and in fact, as I said, that the first release or the first drop at the end of this year will be dual connectivity between NR and LTE. So NR will be working just providing U-plane functionality with an LTE that is doing both C-plane as well as U-plane. So that type of work is ongoing, and there is also work on coexistence between NR and LTE to be able to have NR and LTE coexisting either in the same band or in adjacent bands.
Okay, great. Back to Farooq and maybe Stephen Hayes as well on this question. There was a specific question on E911 call flows in 5G, and I think it's probably worth addressing the broader question of just regulatory capabilities in 5G, both from a services requirements perspective and a core perspective. What kind of progress are we making, and what kind of changes do we expect necessary to meet the regulatory requirements, not only E911, but other regulatory requirements that we see? Do we see a lot of work there? And I would imagine that we've started to look at that in ATIS as well. But Farooq, Stephen, do you want to?
I'll take a stab at it first. So yeah, there's quite a bit of activity going on with respect to at least some of the regulatory requirements, emergency services. There's discussion right now going on support of emergency services in 5G. Just for public PWS and wireless emergency alert, and there was a number of actually CRs, provisional CRs approved last week in CT, which is stage 3, just last week. So a number of companies are pushing some of these regulatory aspects in 3GPP. It's important to make sure that when we deploy 5G, we have a means to support some of these regulatory requirements. Let me see if Steve has any further comments on it, because there was a question from Randy about LMR. I would like to answer that too, but go ahead.
Yes, in general, the philosophy has been that in terms of meeting regulatory requirements, that 5G needs to be at least as capable as LTE. So all that work is being done. I think one area that's struggling a bit is the positioning area, where they're trying to get that included in release 15. But I think in general, the overall goal is to make sure that it supports everything regulatory-wise that LTE supports, and in the early releases.
Yeah, and while we have it, Tom, if you don't mind, there was
sure.
From Randy with respect to interworking with LMR systems, and Randy, I'm sure you're pretty much well familiar with it, that there's discussion already going on in SA6, and the background is that ATIS, we had a group, it was not only ATIS members, but also members from TTA and ETSI and other groups to discuss the interworking between LMR and high bandwidth LTE-based MCC. So that discussion, we actually put it on hold temporarily in ATIS until SA6 becomes up to speed, and we may restart that discussion again in ATIS. Seems like it's time to get the LMR interworking with LTE discussion started. So that is something that we should definitely have a offline discussion and see what do we want to do with that. Tom?
Yes, and Farooq, there's since we're talking about regulatory, there is a question around MME and ECSF. Since they may not be part of the 5G architecture, particularly the MME, and we have a variety of backward compatibility constraints to 4G, as Farooq, you had mentioned. Would this mean significant changes in the E911 call flow, we think, or do we know what the progress is of work on that?
Well, since in the 5G core network, MME functionality, it isn't signaled the same way anymore. Now, most of 5G core networks will continue to support the legacy signaling, so that's expected that would function. But keep in mind that the new functionality, as moving to this service-based architecture, we aren't using so much node-to-node functionality, but we have made additional ways for third-party functions to interact. In addition, I should indicate that as part of emergency calls, since we have new restrictions now on, for example, policies that restrict what devices can do, we have to be able to circumvent those in emergency calls. So there are additional considerations that we have to deal with in emergency calls. But in general, I would say your answer is that most of the 5G products out there, the core network aspect, will continue to support the legacy signaling, so MEs can connect that way. but then how fast they want to, 911 centers can, 911 networks can connect that way, but how fast they want to migrate to 5G signaling, I guess that's going to be up to them.
Yeah, Tom, we only have like less than maybe a couple of minutes left. There's one thing that I would like to bring up. Is that okay if I?
Sure, go ahead.
So the slide that you presented here, I think it was useful to give a perspective of the amount of efforts that are being done in 3GPP. If you just look at one of the groups, RAN Working Group 1, which is on the left side, that group by itself is over 500 people meeting 8 times a year. We can see the amount, the scope of work being done in 3GPP to get this specification done. And I know that could be overwhelming for some of the smaller companies in North America and other places that they, this is like going to be too much work. But I would like to extend an invitation if they want to understand what's going on with respect to some of this activity. ATIS would be a good place that we can understand your requirements and provide you guidance on all overall activities in 3GPP and work with you to get this 3GPP as part of your the activities. So I just like, if it's overwhelming, too much information, please feel free to contact us and we would be happy to work with you. Tom?
Yes, thank you, Farooq. We're coming to the end of the hour here, so I want to thank everyone for joining. Certainly, you get copies of the materials, and please provide feedback on not only this session, but future sessions. There's a lot of detail we can go through, a lot of topics, and we're happy to do this. So thank you very much for joining.